Okay, now we're going to be solving rational equations. And at first glance, they can look pretty complex, but if you break them down step by step, they're okay. So here's a tip. One of the first things that you could do, if you get all of the denominators the same, you can simply ignore them and just solve for the numerator. This is what I'll show you. And technically, you're not really ignoring them. You'd be multiplying both sides, but since they're the same, you wouldn't have to. I'll go ahead and show you what I mean by that. Okay, so when we look up above, this fraction right here has the expression n subtract 3. This fraction is just over n. This fraction has n squared subtract 3n. So what I'm going to do is I'm going to break those down as factors in parentheses. So notice what we have. This expression n subtract 3, this expression n, this subtraction n times n subtract 3. So notice, if you look at on the right side, this is missing the n subtract 3. So if we multiply top and bottom by n subtract 3, these will have the same denominator. And on the left side, well, it has the n subtract 3. It's missing the n. So I'm going to multiply top and bottom. Remember, when we multiply top and bottom, we're just multiplying by a version of 1. N divided by n is just 1. We're changing what something looks like without changing the value. That's kind of the mathematical trick. So I had that rewritten. And now that all of the denominators are the same, if we took the time to multiply both sides by that phrase, that would cancel with both of those. And if we wrote it over here, it would cancel with that. But I'm going to go ahead and undo all of that I just did and show you. So one way that I encourage students to do it is, because that's technically what's being done, once the denominators are all the same, you can kind of ignore it, because that's essentially multiplying both sides by that denominator and they cancel. And now you can simplify. Well, n times 1, let me change the color, is n. 1 times n subtract 3 is just n subtract 3. And we simplify both sides. We get n is equal to n subtract 3 plus n plus 6. Those two can be added together, and negative 3 and 6 can be added together. And then you're going to get the n's to one side, leave the number on the other side. Now you can subtract 2n from both sides, and then divide by negative number, or we could subtract 3 to both sides and subtract that one n. However you would like to do it, as long as you're doing it correctly, I'm fine with that. And then negative 3 is equal to n. And then what you do with your calculator is just plug that negative 3. Make sure you use parentheses when you do it. Each time, everywhere there's an n, plug in. So over here, you would put 1 divide, left parentheses again, negative 3, right parentheses, subtract 3, right parentheses, enter. And you should end up with negative 1, 6. Do the same thing on this side. Make sure you're using parentheses when you need to be, and it should end up being 1, 6. Negative 1, 6 is equal to negative 1, 6, and you should be good. Okay, so I'm going to cover all this up. Now we're going to look at this other problem we have here. Let me go ahead and delete all of that. So when we simplify all this, we could rewrite that as 2 times 2. Oh, I think I did this one over here. All right, I did. So I'm going to break down 4x as 2 times 2 times x because there's a 2 and there's a 2x. So I just broke 4x as it's down to its 3 factors. So 1 over 2 times 2 times x subtract 1 over 2 is equal. So now you're just going to, the largest denominator is 2 times 2 times x. So this is missing 2 times x. So we multiply top and bottom. This is just missing a 2. And I think I probably did that down here. Yes, I did. And then you're going to go ahead and simplify all of that. Well, let me first say, once the denominators are all the same, again, we could multiply both sides, everything by 4x, or let's just ignore it. That's kind of what we're doing when really mentally we're multiplying both sides so that they cancel. And now when we simplify, 1 subtract 2x is equal to 2. We can ignore the 4x right here. And then what we have, get rid of all this stuff. 1 subtract 2x is equal to 2. I went ahead and added 2x to both sides and then subtracted that 2 to both sides. What I have is 1 subtract 2 is equal to 2x. Negative 1 is equal to 2x. We just, last step, have to divide both sides by 2. And then there we have our answer. And then you'd plug that answer back into the original to check the solution. I'll let you do that yourself. Once in a while, even though it works out algebraically, the solution won't work, and that's called an extraneous solution, where it works when you do all of the algebra, but when you plug the solution back into the original, it doesn't work. That's called an extraneous solution. And I think, yep, that's it for this one.